Okay, when we're doing scientific notation, you all know the basics. 4,762 is equal to 4.762 times 10 to the third. Very simple, very easy. When we're making a very large number smaller, we have a positive exponent. 0.00004762 is equal to 4.762 times 10 to the 1, 2, 3, 4, 5. Negative fifth. So when we're making a very tiny number manageable, we have a negative exponent. I find that most students are okay with that. I still draw little bumps on my numbers like a third grader. 1, 2, 3. It's perfectly fine. I don't care if you have little bumps on your paper. Here's where most students screw this up. So a couple notes about scientific notation. Anatomy of a scientific notation number. This first part has got to be between 1 and 9. Okay? To have correct scientific notation, this part of the number has to be between 1 and 9. You can have as many numbers in this section as you need to. And we're going to talk more in this chapter about sig figs, and you'll learn what influences that. This number can be anything. So it can be anywhere from 1 to pretty much infinity. And it can be positive or negative. Okay? So you can have very, very large numbers, very, very small numbers. But again, this number cannot be bigger than 9. And here's where people run into problems. And I do too. So I'm going to teach you my little cheater shortcuts for this, because I screw this up. So if you do a calculation, you end up with 374 times 10 to the third. Is that correct scientific notation? No. We need that to be in the form of 3.74 times 10 to the something. Yes? Now, I'm going to be honest, I struggle with left and right, so I use behind the decimal place and in front of the decimal place. The left and right thing doesn't make sense to me. So what I do when I have to move a decimal is I fluff that number out. So I had 374 times 10 to the third, which means this number was actually 374,000. So I fluff it out, running it one direction, and then I run it back the other. So 1, 2, 3, 4, 5. So this is 3.74 times 10 to the fifth. And I just do my little bumps on the underside when I'm fluffing it out, and I do them on the top side when I'm running the decimal back in. Does that make sense? I find that doing that visual trick really helps me, and I screw this up much less. And I have a lot of students who go, no, you just, count, okay, it's 2 spaces, you add it, you subtract it. I find that students screw it up that way. So you're more than welcome to do that. However, I find that this avoids a lot of problems. And when you are manipulating a number in scientific notation, if you get that power wrong, the whole thing's wrong. So let's try the opposite case. Let's try 374 times 10 to the negative third. And let's see what form that should really be in. So again, I'm going to fluff this number out. 1, 2, 3. So really, that's the number we're looking at. Okay, look online, because this will all be online. We know that we need this to be in the form of 3.74 times 10 to the something. Well, to go back 1 gets us the correct decimal placement. So this is 3.4 times 10 to the negative 1. That's pretty easy, right? Questions on that? I see a few puzzled looks.
I think that confused me when
When what?
I think I knew it better before you did that.
Really? Well, you'll have to show me your method then. You just do it? You're going to run into problems with that. Let me show you some of the kinds of numbers that we get. 47.6 times 10 to the negative 14th. Put that in correct scientific notation. Zoinks! Okay, so we know that it needs to be 4.76 times 10 to the something. Yeah? Okay. Again, I fluff it out. So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Wow, that never works out that well. And then, so that's the number that we're actually looking at. Then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whoops, 11, 12, 13. So this is 4.76 times 10 to the negative 13. The other thing I'm going to say, once you get warmed up, and I always go through this every school year, the first month or so, I come pretty close to fluffing numbers out the whole way. Then I go, oh yeah, okay, so if we're going 1, 2, 3, 4, and we're moving it this way, and you'll start to just get a sense. So you won't have to draw all the zeros forever. Okay, let's do one in the opposite direction. 862 times 10 to the 11th. Okay? So we know that we need this to be 8.62 times 10 to some power. And we know that that's a positive exponent. So we're dealing with some number like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's the number we're actually dealing with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 8.62 times 10 to the 13th. Okay? The problem that I find students have is, here, they know the decimal place has to move 2. So they know that this is going to be 11, it's going to be 2 different than that exponent. The problem is people get confused and I get confused. Is that going to be to the 13th or to the 9th? So if you don't get confused and you never screw these up, then do whatever you've been doing. If you find that you do screw them up when you're moving a decimal place, and again, I don't find that most people have a hard time starting from scratch from a number that's not in scientific notation and putting it into scientific notation. Where I historically, this is based on many years of teaching chemistry, have found that students have a hard time is when they're starting with a number that isn't in the correct scientific notation form and they're moving the decimal. So that's where you really want to be cautious. Okay.